Okay, so it's time to begin. I hope now you're able to hear me, see me, and see my screen as well. Let me introduce myself. My name is Dmitry Vrubo. I am a senior developer in the anyLogistix company in anyLogistix department. And today I will talk about Inside-4-Walls modeling. So our plan for today is on your screens. We will talk about Inside-4-Walls modeling in general, what it is, how it works, and where it could be applied. Then there will be a live demo of our product, anyLogistix, where I build certain Inside-4-Walls behavior in supply chain objects. And then again a Q&A session. Before we talk about Inside-4-Walls modeling, let's talk in general about supply chain problems. There are actually a lot of them, starting from facility placement problem and up to risk analysis. And actually we may lay them out on this axis here, where at the top we'll have a problem which could be solved with very few details, with high abstraction level, and at the bottom problems which could be solved only by implementing a lot of details. So for example, when we use general network optimization, we need very few details, mostly facility locations and some constraints on throughput and so on. While if we want to talk about risk analysis and production planning, we need to add a lot more details. And in general, these two types of problems are solved by two different approaches. Analytical approach, network optimization, GFA, and so on, and dynamic simulation methods. And basically, Inside-4-Walls is a part of this approach, which is dynamic simulation. For those who are not yet familiar with dynamic simulation, let's talk a bit more about it, what it is exactly. So when we do dynamic simulation modeling, we describe supply chain not in terms of points and flows and basically a set of equations and inequalities. Instead, we describe behavior of each object within our supply chain with a set of logical rules. So for example, if we have 4 types of objects in our supply chain, customers, DCs, factories, and suppliers, we describe behavior for each type. For example, customer places orders for 300 units per day, 4 days a week. And then on a DC level, we have initial inventory, which is 3,000 units, and a behavior which is basically an inventory policy that says if our inventory level drops below 2,000, we will order 3,000 more from the factory. And on a factory, we have a certain condition to start production and to produce finished goods. We actually need to order raw materials from supplier when we drop below 100 cubic meters of raw materials, and supplier will provide them unless workers on it are not on strike. Okay, so if we have this behavior described for every object, then we will execute this behavior, these rules over time, over actual modeling time. So we have an axis, and at certain time points, something will happen. So starting with the first day, we have an order from customer. Same goes for second day, third, and fourth one. And at this point, customer ordered more than 1,000 units overall, and the inventory level on our DC is below the reordering point, so it needs to make a fulfillment. On this condition, factory starts production and requests raw materials from supplier, and supplier may be unavailable due to strike. And all of this behavior again will be executed over time, not solved like simultaneously. And as an output of such execution, we'll get the behavior, not an optimal result, not the best allocation of facilities, but the actual behavior of each object in our supply chain. We can keep track of each order, each shipment, and even each product units. Of course, we can see it in terms of animation or line charts or tables and so on. Now, let's switch to Inside-4-Walls modeling, how it is different from the simulation. Or actually, as I said, it is a part of simulation, but it's a bit more narrow. So it's really hard to find, let's say, formal definition for this term. But when we talk about Inside-4-Walls modeling, we want to consider individual properties and internal behavior of each object while considering the whole system. And we actually need to do it when internal behavior can affect the output of the whole system, or vice versa. The whole system state or behavior can affect the internals of an object. And in supply chain analysis, by these objects which we want to work with, we usually mean supply chain objects like factories, warehouses, customers, shipments, and so on. And we want to model insides of these objects rather than just has a black box with an external parameter like throughput. So let's review an example. Let's say we have a factory with production. So we can define the production at the factory quite easily. We can have one parameter which is production capacity per month. So basically how many product units we can produce during 1 month. And we can work with that on a simulation level or network optimization level, anywhere. But if we go to Inside-4-Walls modeling, we replace this production capacity with the number of production lines, production time for each unit or a batch if it's batch production. We should consider schedules, shifts, maintenance, probability of a failure during production, and so on. And if we can do that, can model the internals of the factory, of the production process, then we actually have Inside-4-Walls modeling. When we should use Inside-4-Walls models, what problems can we solve with this? So first of all, of course, we can understand how our internal behavior affects the whole system, or in terms of let's say performance of this object within this system. So for example, if we have a distribution center and we have some throughput on paper, when we model the internals, we can actually find out that there is an internal bottleneck which will make the actual throughput much less than we expect. Also, when we talk about complex randomness and risk assessment, for example, let's say production process comprises 2 steps, and on each step the production time is random with certain distribution. Then it will be really difficult to estimate total production time. So it will be easy to calculate average, of course, but even for deviation, it will be much harder because, for example, if you try to sum 2 normal distributions, the sum of them won't be normal distribution. It will be very non-analytical one. Now, also we can use Inside-4-Walls models when the behavior of an object actually depends on supply chain itself and contains certain decision making. So for example, customer can react on changes in service level. If it receives good service level from the supplier, it will order more. If the service level is not so good, it will order less. Another example, that DC will order not from a specific supplier, but from the one which has the highest inventory level, which is again behavior and decision making. And there are a lot of other cases. So for example, if we want to take into account just-in-time delivery or production in our supply chain, we want to manage our resources, calculate how many do we need, what is the utilization, and so on. If we want to consider lean supply chain, it is pretty much a requirement, because in lean supply chains, even small uncertainty can cause a big break. And also for demonstration purposes. So if you build the internals of an object, you can make it visually look similar as the real-life object, which will make it more pleasant to view, more credible, and so on. Let's actually take a look at the example we have. I have here a model, a supply chain model with a number of customers in 2 distribution centers, quite simplistic one. And if I start simulation experiment over this model, I can go inside the object, inside the distribution center, and see what we have here. And here, let me pause this for a second. We actually have a real layout of a distribution center, a number of resources, which are workers and forklift trucks. We have a certain processing steps, loading time and unloading time with forklift trucks, different zones in our DC, and so on. And if we run it over time, we will see the actual movement of our boxes, of our resources, and so on. And from this kind of model, we can also see how the insights of our DC affects the whole supply chain. So let's speed up it just a bit. Yeah, you see that here we have a service level about 90%, which is more or less okay. But if I reduce the number of forklift trucks, for example, to 3, let's see what happened then. Here on this chart, at the bottom, you can see that our EOT service level drops by a lot, by number of customers, as well as here on this bar chart. I can try to increase it a bit, and service level will slowly start to recover. So this one is a quite simplistic example how the internal behavior of an object can affect the performance of the whole supply chain. And of course, we can experiment with the number of resources not only from the runtime, but in the design time as well. So here in corresponding table, I can take a look at the parameters we have and define the initial number of forklift trucks this specific facility has and change it. Okay, so let's get back to the presentation. And I hope at this point you already have an idea what is Inside-4-Walls models. And now let's talk about how we build them. Now, anyLogistix, our supply chain management tool, integrates a number of optimization methods, for example, GFA, network optimization, transportation optimization, and dynamic simulation, including Inside-4-Walls modeling. And as a first step to this Inside-4-Walls modeling, you can just use standard or default tables we have. So there you can define realistic inventory policies, sourcing policies, which will capture like details of the real supply chain. For example, your own MRP policy if you have one. You can define loading and unloading gates, number, type of vehicles which can be processed at each specific gate, and so on. You can define storage capacity, processing times, limited fleet at each facility, define production time and not production capacity, and also production and sale batches. And to do this kind of Inside-4-Walls modeling, all you need to do is just to fill a table, pretty much like in Excel spreadsheet. But in case of a more complex internal behavior, so for example, a distribution center with a proper layout, you also can do that by creating an extension, basically a customized model for a supply chain object. And it could be done easily. All you need to do is, well, open anyLogistix, go to menu extensions, create new, then select an object you want to extend, for example, factory or distribution center, and then modify this object in extension editor. Please note that this kind of behavior only available in Studio Edition, anyLogistix Studio. And if you currently own PLE version, the free one, you can request a free trial for 2 weeks to try out the Studio Edition as well. Now, what is an extension editor? Extension editor is a customized version of anyLogic. For those who may be not familiar with it, although I doubt that this could be the case, anyLogic is a general-purpose dynamic simulation tool for business applications, and I don't want to talk in more details about it. If you want to learn something, just go to our website where you can find articles, demos, some learning materials, and so on. But still, let's take a look at its capabilities, what you can do with anyLogic. So here I want to demonstrate a model of a factory which produces aerated concrete. And this one is based on a realistic data from the real-life factory with real layout, real times at each production step, and so on. So let me directly switch to 3D animation here. Yeah, so here we can see the actual layout of a factory, a number of cranes, rising area here, number of autoclaves here, and so on. Everything reproduced in with the smallest detail we needed in order to measure the actual performance of this kind of a factory. So you can see movements of each crane, the actual molds for concrete, and so on. So this is the kind of model you can create in anyLogic. Very precise, very detailed one. Okay, let's get back to the slides. And well, extension editor it is not just anyLogic. It's a special version which provides additional features. Basically, simplified creation of supply chain objects with a designated libraries, and an easy integration with anyLogistix. And we will see how it works quite soon. And what is an extension exactly? So, as we discussed, objects behavior usually described as a number of rules. And also you can use process diagrams inside the object where logical rules could be defined as a number of functions which can do a lot of things: calculate statistics, manage resources, describe interaction between supply chain objects, and so on. You can see some examples on the right side. And process diagrams are a sequence of blocks describing ordering, shipment, transportation, production processes, and a lot more. And they could be quite simplistic, modeling just a simple delay, for example, or a bit more complex. For example, this block here models the whole processing at loading gates. And the process itself for the order, you can see from here, very straightforward, from left to right. We have an incoming order which is processed. Then we see if we have enough inventory, and if we do, we will send it to the shipment department. We will process shipment at loading gates, and then it will depart to its destination. And an extension is an approach where you take this default object and modify or extend its diagrams, its functions, or even create the whole new behavior, which is not there by default. After you've created such an extension, you need to put it back to your supply chain model or a digital twin of your supply chain. And it could be done quite easily. So first of all, you export it back to anyLogistix. Then you go to a corresponding table. For example, this is in factories. Then you select the new model, new extension you just created. And it's done. So 3 simple steps. Now, please keep in mind that in this presentation we won't be talking about digital twins, how to create them, and so on. It's only about Inside-4-Walls. If you're interested in digital twin itself, please check our website. We have a number of webinars on different topics, and the last one was precisely about digital twin. Okay, so let's switch to the live demo. I think I'll stop my webcam for now because I can see certain problems. Okay, so let's go to anyLogistix. Here I have a supply chain model which contains number of DCs, 97 customers, and a factory with only one product, with certain inventory policies, sourcing policies defined, and so on. Now, this could be treated as a digital twin of a supply chain, and let's run simulation and see how it works. So we see that we have a perfect service level now, and if we go, for example, inside the factory, we see the process diagram here, where the processing of production is going on. This model contains no extensions, basically no Inside-4-Walls modeling. So let me save the results of this experiment, and then we'll compare the supply chain model excuse me, with Inside-4-Walls models and the one without them. Now, what we want to do, we want to create a number of extensions. First, we will extend factory production on the factory. We'll add there a probability of a failure of our production line. And based on our experience, we would have 2 kinds of failures. Minor ones, which is 90% of failures, and they takes about 30 minutes to fix, and major failures, which happens 10% of the time and takes from 3 to 4 hours to fix. And also we want to extend the customer behavior. We will introduce the idea of loyalty of a customer, which will decrease if we fail to provide the products to the customer within expected lead time, and will increase if we are good at that. Let's go to anyLogistix and we'll create an extension. So I'll go to extensions, create new, and here I'll select a factory and a customer. And here we have it, two models, factory and a customer. Let's start with the factory. So here I have a main object or agent in AnyLogic terms, where we define the production. So first let's change its name from template factory to extended factory. As you may see, you have a number of tips here, what each object does and what do all the functions do. So for now I will just remove them. Now let's alter the production process. So I will make some space for myself here. And here, between the delay which models production of a batch and the moment where we load our product into storage, we will add a failure check. So we'll go to the palettes and then to the process modeling library. Here, first of all, I'll drop here select output block, which checks a certain condition or put production order, in this case, to one of the flowcharts according to the probability. And we know that in 5% of the cases we have a failure, so the probability that everything is fine is about 0.95. Let's also name it here failure check. And in case if something is wrong, we'll add some additional time for fixing these failures. So first of all, we'll find out which failure we have, whether it is minor or major. And we know that in 90% of cases it is minor, and in 10% it is major, like this. Now I'll add a delay here, which defines how much time we need to spend. First one would be minor failure fix, which takes again, as we know, from 20 to 40 minutes. I use here uniform distribution just for a simplicity. You can use normal distribution, triangular, or anything else. And also we have here a major failure fix, which takes from 3 to 4 hours. In 10% of the cases, just like this. And after everything is fixed, we'll go back to the normal process, in this case to loading produced product into storage for both cases. And it is done. So basically I've just created an extension for a factory with probability of a failure with two different cases of failure fixed time. I will save it. And then let's switch to the customer. So customer here has two flowcharts, one for demand and outgoing order, and one for incoming shipments. So we will need to change both. First of all, let's add a loyalty to this customer. So from agents palette, drop a variable object, which will be basically a number, loyalty. Let's assume that it should be between 0 and 1, where 1 means a perfectly loyal customer, and 0, well, actually, let's not make it 0, let's make it minimum 0.5. And it will mean that in 50% of the cases, customer will order products from our supply chain, and in other 50%, it will order from some other supplier, our rival. Okay, so now let's take a look here at the demand flowchart, and here we will check our loyalty. So we'll go back to process modeling library, and here again select output, which we will name loyalty check. And we will say that probability that the order will be placed in our supply chain is just equal to loyalty. And if it is not our order, we will just destroy that. Like this. And I'll also copy this line of code here on this character. It's quite a simple one. It just will tell our statistics object that order status is changed to dropped, meaning we lost this order. It's not ours anymore. Okay, now we have loyalty, which is just a fixed value now. Let's change it. Go back to agent here and add two more variables. In time orders and late orders. We will count them, and based on their corresponding numbers, we will change our loyalty. And here, during the unloading process, for each order, we will check whether it is on time or not. So if our order due time is bigger than current time, it means that it's arrived within our expected lead time. And we will count it in time orders variable, increase it by 1. Otherwise, it is late, and we will also remember that. For those who are not very familiar with the Java or programming languages in general, well, it still could be quite easy. We check when order arrived on time or not, and if it is, we increase the counter on in-time orders by 1, otherwise in late orders. Now, based on overall value of these two variables, we will change loyalty. So we need to, let's say, invent a formula which will make our loyalty from 0.5 to 1, and which will increase with the increase of in-time orders and decrease with the increase of late orders. So, for example, it could be just as simple as this: 0.5 plus 0.5 multiplied by in-time orders divided by sum of in-time orders and late orders. So if all orders are in time, we will have an exactly 1, and if we have 0 in time orders, we will have 0 at the second part, and loyalty will be 0.5. So let me save this. And also, I think I should have done in the first place, I will change the name of a customer from customer template to customer with loyalty. Just like this. Now, let's put these models back to anyLogistix. So we will export them, and I'll have a notification here, and the factory as well. Done. Now go back to our supply chain model here, and I will change all customers to new customer with loyalty type, and our factory now will be extended factory. So let me quickly check something here. Yeah, everything looks fine. So let's run this model and see how our supply chain will behave now. So again, we start with the perfect service level, but after some time you may see that our performance drops, and well, some customers, approximately 1/3, receives not very good service level, and due to this behavior, we have some orders dropped. You may see how many orders we dropped at each customer. So let me restart it quickly. And let's take a look at the internals of an object. So start with factory. Here we can see how during our production we will receive failures. So number of minors so far and no major. Let's speed up a bit. Yeah, and now we had one major failure as well. Let's also take a look at the customer, this one. So we see that it has it received a number of orders, all of them in time. Let's again speed up a bit. So we start to fail to deliver products in time. So our Aurora customer, the one which is located within the city, receives a number of late orders, and his loyalty drops. But again, we just observe the internals of an object. Let's see how it affects the whole supply chain. So for example, let's take a look at the P&L table here. Here we have a profit which is approximately 260 millions US dollars, and we have saved statistics from the previous run without this Inside-4-Walls behavior. Let's compare them. Here our profit is about 3 millions more. So only on this probability of a failure and implementing the loyalty of a customer, we lost about 3 millions of profit. So this was a quite simple example of what you can do, how can you create your own extensions, your own Inside-4-Walls behavior. Let's get back to slides now. And I also bring back my face. Okay, everything here was covered, right? Now, we can extend not only supply chain objects, but a lot of different things in anyLogistix, I mean. Different policies, inventory policy, sourcing policy, transportation cost calculation. We can add custom statistics. We can add more tables to anyLogistix if you need. We can also create additional connections to a databases or online services and add custom process to experiment results. All of this done through an extensions mechanism with anyLogic usage. Sorry. Now, we usually divide extensions in number of groups. The one we just saw was quite simple, so even if you're not very familiar with dynamic simulation and anyLogic itself, you can try to create something like this. It's quite easy. Now, if you want to add more complex logic in your extension, you may need certain anyLogic knowledge, for example, by completing anyLogic training course or by reading the book anyLogic in 3 days. In case you, for example, want to create a really complex inventory policy, you also need to know something about Java programming. And if you actually want to create your own experiment, you want to add integration to your BI tool, you really need to be good in both anyLogic and Java. So if you need some help, you can always contact our support team, which can handle all kinds of extension complexity, which will respond to you within 48 hours. And will provide you with a draft with some tips, or maybe even with the fully prepared extension you want. So please remember this email address, support@anyLogistix.com, or you can just use this get support button from anyLogistix. So a short summary of what we discussed today. The Inside-4-Walls modeling required for certain problems in the supply chain, and in anyLogistix you can do it by an extensions mechanism, and you can extend basically everything you see in anyLogistix, but you will probably need some knowledge of anyLogic to create complex extensions. So that's mostly it for today. Now, let's see what kind of questions you had during the webinar. We have some time for this. Apparently a lot. So, as usual, we have a question about the recording. Yes, we record this webinar, and the recording will be sent to you in a few days. along with the presentation with all materials, so no worries here. Okay, one more question about PoE. So extension mechanism is not presented in a PoE version. If you really want to try it, I suggest you to request a trial for anyLogistix Studio. It's a free trial for 2 weeks, so you can get familiar with this approach. So in order to obtain a free trial, you can actually email us to this address or go to our website in download section. But I think email will be better. Why this supply chain can be considered as a digital twin? I suppose it is about the last example we had. Well, in order to understand what is digital twin and what is the difference between just simulation model and a digital twin, I recommend you to watch our previous webinar, which was exactly on that topic. It's about an hour long, and you can also find it on our website. Let me show you really quickly. So as you may expect, it is anyLogistix.com, and here in the resources section we have a video tool with number of demo videos and webinars. And the last one, supply chain digital twin. So I recommend you to take some time to get familiar with them, but keep in mind that it's still better to participate in live events, because this page updated like months later than the actual webinar, and here you cannot get a live session with me, for example. And about trial version, just to quickly show you this big red download button here, and here request a trial version, where you will need to fill some fields here, and there is actually no requirements to get a 2 weeks trial, and in certain cases it could be extended if you really need to, but this should be discussed with our sales department. Can we use other tools to create an extensions? No, we only support anyLogix. Well, not exactly anyLogix again, customized version of anyLogix, but still only it. Well, obviously by 2 reasons. First one, it's a tool made by our company, the anyLogix company as well. And second reason, well, at least from my experience, it's quite good and much more convenient than Arena, for example. Of course, it depends, but in my opinion, anyLogix has everything covered. Okay, I've got another question here. In a DC, for example, can we define an object, for example, forklift truck operator, to do both operations? Well, of course, we can define any number of operations workstations which can share any number of resources, operators, some machine, or whatever else. And actually, we have an example in anyLogistix itself. Let me quickly show it here. It is available from Help Import Example menu, and it is called DC with staff. And it basically does exactly what you asked about. We have a loading process and unloading process, and we have a shared resource pool with a number of workers which make these 2 operations. So here we have number of workers, and here we have unloading and loading, and these people do both operations here. Let me show it slower. Yeah, like this. And again, it is available in help, import example, simulation, and here the CV staff. So I can see no more questions now. If you understand that you have questions sometime after this webinar, again, don't hesitate. You can contact our support team. If it is a question to development team personally, they will pass it to us and we will answer them in no time. So don't hesitate. As soon as you think about something, get support or feature request buttons are there for you. And I think now it's really it for today. Again, thank you very much. Hope you like it, and I hope to see you next time.